1.4 or other effective sampling methods, there's going to be 5, I think is it 5 or is it 4? It's just 4 that we'll learn. So simple random sampling that we did in 1.3 is one of them, and then we're going to learn 4 new ones on here, okay? So what we have going on is the first one is a stratified sample. Do you guys know what the word stratified means? Kind of layered or chunked, like, or strata is, you know, crust, mantle, that kind of stuff. So a stratified sample is obtained by separating the population into non-overlapping groups, bless ya, called strata, and then obtaining a simple random sample from each stratum. That's just the singular. The individuals within each stratum should be homogeneous or similar in one way. So basically you have your population, and what they did, they separated it into strata. So in this case, it was gender. So with your population, you have to separate them into groups some way, shape, or form. So they did males and then females. I might do, your last name starts with an A, your last name starts with a B. That could be strata. And you're always in one or the other. That's what they mean by non-overlapping. You can't be, you have to choose. And I know this day and age, it starts getting kind of iffy with stuff like that. Like hair color, I'd have to choose blonde or brunette, one or the other, okay? So once you have your separations, once you have your strata, you take a simple random sample and you get your sample, okay? So we're going to have strata, and then we're going to have a simple random sample. Will you underline those, guys? You're going to have strata first, so some kind of division, and then a simple random sample. So division, then a simple random sample. All right? And how you get that simple random sample? Totally up to you. You might like that random number table or the calculator, or like a lot of people do, just Google a random generator. All right? The second objective is obtaining a systematic sample. If you gave me a roster and asked me to pick 5 people, this is how I would do it. I'd go every 5th person or whatever it may be. Is anybody else like that? I think that's the OCD in me. Like, it just makes it really easy. I'm just going to count every 3, and you guys are going to be my sample. That's what a systematic sample is. So a systematic sample is obtained by selecting the kth individual. So this is who you start with. Oh, no, it's not. Sorry. This is how many you count by. So if I'm picking every 5th person, my K would be a 5, okay? The first individual is usually denoted with a P. The first individual is usually denoted with a P. And it obviously has to be between 1. So if I'm choosing every 5, my Pth person, that sounds so weird, can be 1, 2, 3, 4, 5. It can't be 10 if I'm choosing every 5. All right, they make it way more complicated than it is, but let's just look at this example. They have 11 people there, and they started with person 2, but then they went to 5, 8, and 11. So what are they counting by? 3. So your K is 3. Is that okay? That's how many you're counting by. Who'd they start with, though? Person number 2, so that's your P. All right? The reason why I'm pointing that out is because they have this crazy formula down here that lets you know how to do it if you have a really large sample. I would probably just go like this, you know, but there's a quick way to do it. All right, let's start by looking at these instructions. Number 1, approximate the population size. What do you know? What is population size denoted with? A big N, right? After you know who's in your population, you need to come up with your desired sample size. What do you know? It's designated with a little n, all right? So what's the easiest way to come up with your kth person? Divide n by n. So the value of this is k. So k is big N divided by little n. But you always want to round down to the nearest integer. And I know that's kind of weird because if you get like 4.8, you want to round up to 5. But if you start counting by 5s, you might jump over the last person. So you're always kind of hesitant, and so you're only going to count by 4s, so you don't go past the last person. It says randomly select the number between 1 and k to start with. Remember, P is who you start with. And this, I know it looks crazy, but this is technically the same pattern they have here. Who do you start with? P. And how many are you counting by? K, right? So the next person would be K, and the next person would be, okay, I counted over 2K, I counted over 3K, and 4K. Do you guys see that? I know it's kind of a lot of variables at you. But P is the person you started with, 2. And K is the number you're counting by, 3. So what's 2 plus 3? 5. Who was the next person we picked? 5. And then what's 2 times 2, or excuse me, 2 times 3, 6, right? But we started with P. What's 6 plus 2? 8, and so forth. It's just a pattern that somebody was able to calculate. And then, of course, at the very end, notice you keep adding K, 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 K. You keep adding those. At the very end, you have 1 less K than your sample size, all right? So let's see if we can make it work on here. On the example, it says, the Human Resource Department at a certain company wants to conduct a survey of worker morale. So they want to know how their workers are feeling. The department has an alphabetical list of 4,502 employees. How would it conduct a systematic sample? So A, let's first determine K if the sample size was 50. So how do we figure out K, guys? It's this formula up here. We're going to take big N and divide by little n. What is big N in this case? 4,502, right? That's the population. That's all the employees we have. What's little n in this case? 50. When you do that division, it almost goes in perfectly, but not quite. What do you guys get? 90.04? Is that okay? Does that look right? But we have to round down, so it's 90. K equals 90. Sorry, I squeezed in the K equals, so it's a little tight. All right, so if this was 90.8, your K is still 90, all right? We don't want to go to 91 and jump over the last person. All right, so they want us to determine the individuals chosen if we start with the third employee. So they told us who we're starting with. Who we start with is always denoted P. All right? So what I'm going to do, guys, is I'm going to steal this little generic formula, P, leave a little bit of room, P plus K, leave a little bit of room, P plus 2K, leave a little bit of room, dot, 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 P plus N minus 1K, okay? And the reason why I'm doing this is because on my math lab, they're not going to want you to ask, give you every 50. You know what I mean? We're having a sample size 50. That's a lot. So they're going to ask you to fill in these blanks. Who are the first 3 you choose and who's the last person you choose on that list? So they want you to see, like, we can all do this, count by 90, right? But they want you to show them that you can continue the pattern and also come up with that last person that you're choosing. All right. So you have your puzzle. You have your puzzle pieces, 90 and 3. So we're just going to plug it in. Okay, so who's the first person we're choosing? We're choosing P, and they told us to start with employee number 3. Do you guys see what I did there? The first person you choose, they told us, all right? But now we're only just jumping by 90, so a lot of us can do it without the formula. If you're jumping by 90, you started with person 3, your next person is going to be 93, and your next person will be 183, and your next person will be 273, right? But some people can't do that in their head, and so we can just follow this formula, right? I'm going to just put it up here small. The third person is who we started with, and we determined our K was 90. So to figure out person 2, we just have to take P plus K, 3 plus 90, or 93. But we knew that, right? We knew we were going to count by 90s. So when we do this next formula, we hope to God that it ends up being 183, right? So P is always the first person who we started with. That was the third employee. Plus 2 times 90. Right? Order of operations, we have to do multiplication before we do addition. So what's 2 times 90? 180. What's 180 plus 3? 183. And guys, you would just keep doing that. You would have P plus 3K, P plus 4K, and so forth. All the way to the very end. So let's figure out who this very last employee that's going to get chosen. P was who we started with initially, plus, what's little n stand for? 50. It was our sample size, right? So we have 50 minus 1 times our K, which we decided was 90. Guys, if you write this exactly, or excuse me, type it in your calculator exactly how you see it, 3 plus parentheses, 50 minus 1 parentheses times 90, you'll get the right answer. Or you can kind of do a little bit in your head. We know that 1 less than 50 is 49. You can take 49 times 90 and then add that third person to it. When you do that, guys, do you get 4,413? Is that okay? 4,413. And guys, look how close that is to 4,502. So this just shows you if we counted by 91 50 times, we might have popped over 4,502. So it's always better to play it safe and round down. Okay? So stratified, divide them into separate strata and pick a random sample. Systematic is just every fifth, every third, that kind of thing. All right, our last two, you guys are doing awesome. And one's really easy, okay? So cluster is just kind of a little bit more difficult. Cluster honestly reminds me a lot of stratified, okay? So a cluster sample is obtained by selecting all individuals within a randomly selected collection or group. So you're going to divide and choose all. And that's what's different. Okay? Notice that they still have division. So we have person 1 through 24. And they're grouped into chunks of 4. So it almost looks like it's strata, right? It almost looks like there's strata. But instead of randomly choosing people from each of those groups, the whole group was chosen. So that cluster was chosen. Therefore, it's a cluster sample. So both stratified and cluster are going to kind of start off the same, where you kind of hear or see the word of division. But if you take a simple random sample, it's stratified. If you take a cluster, it's cluster. All right. Last one, I think this one cracks me up because this is the way we would all go if we could, is a convenience sample. What's the root word in convenience? Convenient, right? It's just a sample where individuals are just really easily obtained. You're like, ugh, my teacher's making me sample people. What do? Ask the people you live with, poll on Facebook, anything that's very easy, right? So Twitter voting. So anymore, and I know it's like just changing with the times, but back in the time, like when I was growing up, we would watch Dateline and be like phone-in polling. It's like, call us with what you think, right? Or even American Idol started that way. You had to call to vote on the person. Now you can like do the hashtag so-and-so, and that's the winner you want, that kind of thing. So why is this convenient? Because you can just put it out there, and you don't have to do anything. Everybody else does it. How about, I'm trying to think what else is, asking family members, right? Do you really have to go out of your way? Not usually, to ask your family, okay? What is, this is the least effective, right? It's not gonna, you're gonna have some bias. Like if I wanted to just ask you guys because it was easy, I would do that, but it wouldn't be a very good sampling technique. All right, last couple things before we try it on our own. Multi-stage sampling is exactly that. It's multi-sampling. So maybe you start with the convenience survey to get some answers, but then you randomly select from that, okay? So it's using a combination of sampling techniques. It's using a combination of sampling techniques. So you could start with a convenience sample to kind of narrow down the playing field, but then once you got your initial chunk of people, maybe like 100 people responding to your Facebook poll, then you might randomly select from there or do a stratified one from there. All right, last thing before we try it on our own. You guys are doing great. We got through 3 sections today. Sample size, it's something that I kind of mentioned on Monday when it comes to that data collection sheet. The bigger, the better. Sampling size, the bigger, the better. The more people you can ask, the more accurate your information is going to be. So don't stop with just 2 people. Maybe do 20 or 40 or whatever it may be. Is that okay? So before we end, let's do this. This is really similar. Actually, it's basically identical to what you would see on a test. Okay? What I will do is I will tell you the names. You don't have to memorize the names. You just have to know what each one is, okay? So in the directions, I'll say, identify the type of sampling. Cluster, convenient, simple, random, stratified, and systematic. Which one would be used to get each of the following samples? So this is identical. Each one is going to be used once. I'm going to list them all up in the directions, and then you got to choose which one is which, all right? So let's look at A. An evaluation is passed out to every 5th person attending a guest lecture series. Systematic. Keyword, every 5th person. Whenever you're counting by the same amount each time, that's always systematic. Is that all right? These are kind of tricky. I think this in your worksheet's harder than your homework, I think. B, a farmer divides, so notice that, okay, so we have division. He divides his orchard into 50 subsections, randomly selects 4, and samples all the trees within those 4 subsections to approximate the yield of his entire orchard. So which one do you divide but then select all of them? Cluster. And at first, it kind of fooled me because I read his orchard into 50 subsections, randomly selects 4. I'm like, oh, he's a random sampling. But that means that's just the 4 he's looking at, and then he chooses all of them, okay? C, to determine, you know you're going to do this, to determine his DSL internet connection speed, Sean divides his day into 4 parts. So again, you see that word divides. Morning, midday, evening, and late night. He then measures his internet speed at 5 randomly selected times during each part of the day. It's not simple random because we have that division first. Which one was it when you divided first and then you randomly selected? Stratified, you got it. So each chunk of his day, morning, midday, evening, and late night, are the strata. And then he's randomly selecting times during those chunks. D, you survey 5 friends regarding their opinion about the quality of food in the cafeteria. Convenient, right? 5 friends. They're very easy to ask. Is that okay? All right, last one, process of elimination, but let's make sure it makes sense, okay? 24 Hour Fitness wants to administer a satisfaction survey. They use a list of all members and then randomly select 40 club members about their level of satisfaction. This one's not as good as what I probably would give on a test. I would say they use a list of all members and randomly select 4 members using their calculator or using the random number table, right? So that's just our simple random sample from section 1.3. That's an SRS. So we have all the members, but then we're just randomly selecting, no order, shape, or form.